Hello everyone, this is Wanwali from Tsinghua University. Today, I'm very happy to present our paper Label2Label, a language modeling framework for multi-attribute learning. Multi-attribute learning aims to predict the attributes of objects accurately. It involves many important tasks including facial attribute recognition, pedestrian attribute prediction, and cloth attribute recognition. Most existing approaches adopt a multitask learning framework, which formulates this question as a multi-label classification task. The key challenge of this task is modeling the complex relations among different attributes. For a given sample, many of its attributes are correlated. For example, the attributes of beard and woman are almost impossible to appear on a person at the same time. Modeling complex inter-attribute associations is an important challenge for multi-attribute learning. For the first time, we propose a language modeling framework for multi-attribute learning to model complex sample-level attribute correlations. Let's first see how NLP learns complex relations. As a representative work, BERT utilizes a masked language model to capture the word co-occurrence and language structure. Inspired by the success of BERT, we regard each attribute label as a word, which describes the current state of the sample from a certain point of view. As each sample is attached with multiple attribute labels which are used to depict the same object, these words can be organized as an unordered yet meaningful sentence. Then we use masked language model to learn attribute relations. Although we can directly use the real attribute labels as the input of the masked language model during training, we cannot access these labels for inference. To address this issue, we introduce an attribute query network to generate the initial attribute predictions. These predictions are then treated as pseudo-labels and used as input to the masked language model in the training and testing phases. Our attribute query network learns a set of query vectors. Each query corresponds to an attribute type. Our experiments found that the masked language model still can't improve the performance. The reason is that masked language model captures the word co-occurrence by constructing this task. Here I use M to denote the random masking operation. It leads to two problems. The first problem is that masked language model only captures statistical attribute correlations. The second problem is that masked language model and attribute query network cannot be jointly trained. To address these issues, we propose an image-conditioned masked language model, which recovers the masked words, conditioned on the masked sentence and image features. Introducing the image condition is not trivial, as it fundamentally changes the behavior of masked language model. With the conditions of the image, the constructed task is an accurate one-to-one mapping. Here we show the overall framework of our work. We conducted experiments to show how image-conditioned MLM improves performance. We considered two network architectures to implement MLM, transformer decoder and MLP. The results show that none of them improve the performance of the attribute query network. The reason is that MLM only learns statistical attribute relations, and this prior is easily captured by attribute query network. Meanwhile, our ICMLM learns instance-wise attribute relations. We jointly train ICMLM and AQN, which achieves significant performance improvement. These results illustrate the superiority of our proposed ICMLM. Results on several tasks show that our approach achieves SOTA results compared to highly tailored task-specific methods. Our method also generates better interpretable predictions. We visualize the attention scores in the transformer decoder. The positive attribute labels of each sample are listed in the corresponding bottom left corner. For the first sample, we see that attribute male is strongly related to the positive value of 5 o'clock shadow, and the negative values of wearing lipstick and wearing necklace. For the second sample, the attribute heavy makeup assigns more attention to the positive values of the attributes wearing lipstick, wearing necklace, attractive, and arched eyebrows. So, we see that the related attributes tend to have higher attention scores. Thank you for listening. For more information about this paper, please visit our websites.